Okay, our lesson today is 3.1 Graphing Quadratics from Vertex Form and Transformations. The equation we'll be focusing on today is y equals a parenthesis x minus h squared plus k. Our first example is y equals negative 2 x minus 3 squared plus 8. First, we'll have to identify a, h, and k. Our a is negative 2, our h is 3, and our k is 8. Then we'll have to figure out our vertex, which is 3, 8, because it's h and k. Then we'll plot it on the graph. 3, 8 vertex. Then we'll make a table of x and y, trying to figure out our other points, and vertex is going to go in the middle, 3, 8. And we're going to fill it out numerically, and we're going to use a system of 1, 4, 9 and multiply it by a. Then we'll get negative 2, negative 8, and negative 18. 2 will be 6 because you're subtracting 2 from 8, and then 4 will also be 6, 1, and 5 will be 0 because you're subtracting 8 from 8. Then you'll plot the points on the graph, which is 1, 0, 2, 6, 3, 8, 4, 6, and 5, 0.
Well, and they just typically don't run a temp, so I don't always base the judgment on that.
Then we'll identify the transformations, and since a is negative, it'll open down, and it's going to be a vertical compression because it's outside of the parentheses and it's less than 1. Then it'll shift to the right 3 because it's positive 3, it's x minus positive 3, and it'll shift up because it's positive 8. Then we'll identify the x-intercepts, and on the x-axis, there are 2 points that cross it, and it's 1, 0, and 5, 0. So our x-intercepts are 1 and 5. Then for our y-intercepts, it crosses 0, negative 10, because on the graph it shows that when it goes down, it crosses the y-axis. Our axis of symmetry is always our h, which is 3 in this situation. And our domain is all real numbers because the parabola continues, because there are arrows. And the range is y less than or equal to 8 because it'll always be rk.
So our second equation is y equals 1/3 x plus 2 squared minus 5. So first we have to identify our a, h, and k still. So our a is 1/3, our h is negative 2, and our k is 5. We know our vertex is negative 2, 5. So I'm going to start to draw my graph, and I'm going to label my x and y axis. I'm first going to draw the point, which I already know is negative 2 and 5. And then I know that our a is positive, so the graph is going to have to open up. To find my other points, I am now going to plug in numbers to our equation. Just like we did in the table, and using our parent function, we're going to use the square roots of it. So I'm going to have 1/3 times 1 squared, and that's going to equal 1/3. I'm going to have 1/3 times 2 squared, which is going to equal 4/3. And our third one, we're going to have 1/3 times 3 squared, which is going to equal 9/3. And you can see the 1, 2, 3 is a square root of the 1, 4, 9. So now that I have my outputs, I'm going to use the input that I have, which is 1. I'm going to go right 1 and then up 1/3. And the same on the left side. And then I'm going to go to our 2 and go left 2, up 4/3. And I'm going to do the same on the other side. And then for the last one, I'm going to go right 3 and then up 4/3. We didn't have enough room, so I'm just going to draw my parabola, and it's going up. So the next thing that we're going to do is we're going to do our transformations. So as you can see, it is a vertical compression because our a is a 1/3, and we know that it's going to shift left 2 because our h is a negative 2, and we know it's going to shift down 5 because our k is a negative 5. The x-intercepts are negative 11 and 7 because that's where it crosses the x-axis. Our y-intercept is going to be 0, negative 5 because that's where it crosses the y-axis. Our axis of symmetry is going to be negative 2. It's always the same as the h, and you can see it splits both sides equally. And then it's going to be a minimum point because the graph opens up. The domain is always all real numbers because it goes on forever, and the range is going to be y is greater than or equal to negative 5. And our negative 5 is our k, so you can see it matches. And our last equation is y equals 4x minus 1 squared plus 7. So we're going to identify our a, h, and k. Our a is 4, our h is 1, and our k is 7. So now we know our vertex h and k is 1 and 7. I'm going to start and draw my graph and label our only point that we know, which is our vertex 1, 7. And label it 1, 7. And then next I'm going to use my same parent function 1, 4, and 9 and multiply it by our a, which is 4, so 4 times 4, 1 times 4, 9 times 4, and then it's going to equal 4, 16, and 36. Next I'm going to make my table of x and y's and put all my x's in there that I need and start with my vertex. And then to find the y, I'm just going to add 4 to 7 and 16 to 7, that's going to give me my 23. And then I'm going to plot all these points onto the graph, just like I'm doing right here. So negative 1, 23, and 0, 11, 1, 7, 2, 11, and 3, 20. So we can see that our A is a positive, so the graph is going to go open up. It's going to shift right by 1, not 3. I don't know why I put 3, but that's wrong. It's going to shift up by 7 because that is our K. And the axis of symmetry is 1 because it's always going to be the same as the h, where it separates the parabola into two equal parts. There's no x-intercept because it never crosses the x-axis. We can see here that the y-intercept is 11 on the table, and here on the graph it crosses the y-intercept. And so now we know that our y-intercept is 0, 11, and it is a minimum point because the graph opens up. And that is how you graph quadratics using vertex form. Thank you for watching Elizabeth and Kaylin's Algebra project.